Hello guys, welcome to the second course of trigonometry. Let's start it.
Properties 1. If two angles alpha and beta be 90 degree, we can say sine of alpha is equal to cosine of alpha, and not only sine is equal to cosine when alpha and beta sum of them be 90, but also the tangent of alpha is equal to cotangent of alpha. Therefore, let's complete this part. The sine of 30 degree is exactly equal to cosine of 60 degree, and sine of 10 degree equal to cosine of 80 degree, and tangent of 10 degree is equal to cotangent of 80, and tangent of 30 degree is exactly equal to cotangent of 60 degree. Yes? But another property is so important. At the first, in the previous, what we understood. When we have two angles, these two angles summation is 90 degree. One of them we give to the sine, and another one we give to the cosine, they are equal. Or another one, when we have two angles and the summation of them is 90 degrees, and when we put one of them to the tangent and another one to the cotangent, they are the same. Okay, but another thing is so important. For every angles, tangent alpha times cotangent of alpha is 1. Why? It's so simple. Because tangent is sinus alpha divided to cosine alpha, and cotangent is cosine divided to sine alpha. They can immediately cancel each other, and therefore these cancel this cancel this, and answer immediately be 1. But let's give some example. Tangent 20 degree cross cotangent 20 degree is equal to 1, or tangent 45 degree cross cotangent 45 degree exactly is 1. But another one, at the property 2, tangent and cotangent when they product together is equal 1. But in property 2, when alpha and beta be 90 degree, tangent alpha times tangent beta are 1, or cotangent alpha times cotangent beta are 1. Why this happen, guys? If you be a little genius, when alpha plus beta is 90 degree, tangent of beta is exactly a cotangent of alpha, and we put in here exactly is property of 2. Therefore, in the property 2, tangent and cotangent for every angle is true. But in property 2 is just true when alpha and beta is different, but the summation of them is 90 degree. For example, let's give an example. Tangent 20 degree cross tangent 70 degree is exactly 1. But let's go to the important things. You know what is the unit circle? When we gonna to calculate, for example, if I'm gonna tell you so important things. When you are in Cartesian coordinate, you have this axiom x and y. When we are in trigonometry, we are in unit circle like this, and we can select the angle by this. For example, when I say please find the 30 degree, you must go from this is positive and this part is negative. When I say you find me 30 degree, you can and tell yes is 30 degree. I tell you count me 100 degree until here is 90, 180, 270. For example, 100 is here. This angle is exactly is 100. But if I say you please choose minus 50 degree, you must start from this part, and you say, oh, it's between 0 and this part, and exactly maybe this 50. Okay, therefore our coordinate in trigonometry is a unit circle. But in the unit circle, not just we select the angle, it's so important property. You consider in the here our right triangle hypotenuse is 1, and right now write me sinus and cosine. Sine and cosine, what's happened for them? When hypotenuse is 1, the opposite side to 1 is exactly opposite side. Is exactly this value is a sine of gamma. Exactly this value, guys. But cosine of gamma, this angle, is exactly adjacent divided to hypotenuse, and adjacent is exactly this part, because is adjacent and because hypotenuse is 1. But it's so important things, guys. Why? Because in the triangularity, the x coordinate because this point fall to this part be y, and this point fall to this point and exactly is x. And therefore it happens so important things, triangularity or trigonometry. When we put in unit circle, x is equivalence with cosine and y is equivalence with sine of alpha. Because as I mentioned earlier, when you put any angle, for example this, when we put in x coordinate, this value is our cosine of this, for example, beta, and this value is exactly our sine of beta. We're gonna to use from these important things. But in the unit circle, you know, this is x axiom, y axiom, and its first quadratic is in unit circle. This is the first quadrant, is second quadrant, and this part is third quadrant, and this part is fourth quadrant, you know, when you was a child. But we're gonna to recognize what's happened for trigonometric ratios in first, second, third, fourth quadrant. In the second, you know, if you put any angle in here, x is positive because it's positive 1, minus 1, and positive 1. Because x is positive, therefore x related to cosine. Cosine is positive, the axiom, and therefore sine is positive. What about the tangent and cotangent? You know, the tangent and cotangent is division of these two factors, and they are also positive. But in the second part, in the second quadrant, you consider this angle name, for example, C. When you put in the y is positive, that means sine is positive. But when you put in the x axiom is minus, and therefore cosine is negative. But the tangent and cotangent, one of them is negative. Therefore, the fraction is negative. But about the third quadrant, you know, when you put any angle put here between 180 degree and 270 degree, not only x is minus, but also y is minus. X is minus, that means cosine is minus. Y is minus, that means sine is minus. What about tangent and cotangent? You know, the tangent and cotangent is division of 2 minus is positive. Therefore, tangent and cotangent is positive. But in the fourth one and the last one, when you put any angle, for example, in here, this angle put in here, you know, the y is negative, and therefore sine is negative, but x is positive, and therefore cosine is positive. But tangent and cotangent, what's happened for them? Yes, one of them is negative, and the total tangent and cotangent is negative. Some people, they gonna to summarize this better. At the first I told you, you understand what's happened for them, and after that I gonna to summarize them. If I gonna to summarize this part, which of them is positive in 1, 2, 3, 4 quadrant? In the 1, all of them is positive, but in the 2, just y is positive because in top, therefore y is sine is positive. In the third, x and y is negative, but division is positive, and therefore cotangent and tangent are positive. But in the fourth, just x is positive, and therefore when x is positive, that means cosine is positive. Let's go to another example. Right now we can solve it by this report. Suppose angle alpha lies in the third quadrant and suppose angle alpha lies in the third quadrant. Alpha is minus 1 divided 2. Show that other ratios. Therefore, if you consider what is the triangularities, what is the trigonometry ratios, it's happen in right angle triangle. Therefore, when we say sine of alpha is minus 1 divided 2, minus is not work in geometry, therefore is alpha is 1 and opposite side is 1 and hypotenuse is 2. How we can solve this x? Immediately you know this can calculate by Pythagorean theory is 2 plus 2 minus 1 is root square of 3. Therefore, this is root square of other things. But the cosine of alpha is adjacent to hypotenuse is root square of 3 divided 2. What is so important we are in the third quadrant. In the third quadrant, guys, you must consider in the third quadrant the x is minus, and the answer of this is minus Okay, but in the another one, the tangent of alpha is opposite divided to root square of 3, and if you're gonna to write better is root square divided 3, but cotangent of alpha is flip side of tangent is 3 divided to root square. If we're gonna to write this, we can cancel this, and answer is root square of 3. But they are positive, yes, because in the second quadrant, tangent and cotangent are positive, but sine and cosine are negative.
Thank you for watching this movie. Please like and subscribe our channel. Bye bye.